at 2.2 from our textbook. Now we're going to start thinking about trig functions of non-acute angles. In the last section, we were talking about trig functions for angles that were less than 90 degrees. Now we're going to look at anything else that can go from 90 degrees up to 360 degrees. And we're going to use the information we had from the last section to guide our thinking. The first idea we need to tackle is called the reference angle. All of the reference angles are going to be between 0 and 90 degrees. So it says that they are a positive number, acute meaning between 0 degrees and 90 degrees. And that's because the angles that we were just talking about and we know the trig values for come from the first quadrant, right? And if I have an angle that's in the second quadrant, like I do in this first picture, the angle that I'm going to consider is right here. This angle that I'm highlighting is less than 90 degrees. In the third quadrant, I'm looking at this angle, which is also less than 90 degrees. And then in the fourth quadrant, this is also less than 90 degrees. The areas that are listed in pink, those are where we're going to look at the angles. Now, there was a picture that I drew in class about a bow tie. I'll show you what how that comes into play. We were saying that when we are looking in a particular quadrant and we are drawing a triangle, that the right angle always has to come perpendicular to the x-axis, and that the angle is going to be right next to the origin. Well, similarly, if we were in the second quadrant over here, and we were to draw a triangle, here's the right angle, and the angle is here. Well, technically, that's called the reference angle. What we mean by that is the angle that we're actually looking at, angles always start on the positive x-axis, and then the terminal side is here. The angle is going like this. Let's say that that angle is 120 degrees. But the angle that we're going to consider is just this one. That's called the reference angle. The measure of this angle would be 60 degrees. And the reason we're going to consider that is because if we know, as we do, what the sine and the cosine and the tangent of 60 degrees are, then we can use that to figure out what the sine and the cosine and the tangent of 120 degrees are, because these two triangles that I've drawn should be identical. They're just in different places, right? One's in the first quadrant, one's in the second quadrant. Following those same ideas, this was 120. Following these same ideas for the third or the fourth quadrant, we could have a triangle down here. Again, the reference angle is here, and it's because this triangle has been rotated from back over here, right? It's been rotated all the way around. But the angle that we're actually considering goes from here all the way to here. But we're just looking at this little piece of it right here. And then in the fourth quadrant, the triangle is going to be down here, and the reference angle is here. This, let's take a look at this website here. I'm going to pause and open up this website that'll show you a visual of how to find the reference angles. It's called GeoGebra. It has a lot of geometric and trigonometric applets that you can use to see something. I've got an angle or a triangle here in the first quadrant, and I can see that the angle that we're considering is 52 degrees, and the reference angle is the same. So I can take that point P and I can move it around to get, let's say, like a 30-degree angle. and the reference angle and the actual angle are the same. But when I go over here, let's say to 120 degrees, this is what we were talking about. The blue angle is what we're actually measuring, right? It goes from the positive x-axis to the hypotenuse of the triangle. But the reference triangle or the reference angle is the little angle in red that goes from the terminal side of the angle to the x-axis. So the reference angle is going to be 60 because this triangle is going to be exactly the same as if I were over here at 60, right here. Oops, a little bit over 60, right? They'll be in the exact same location. If I go all the way down to the third quadrant, let's say to, what would 180 plus 60 be? 240. That same size triangle has been flipped all the way around. Even though the angle we're looking at is 240, again going from the positive x-axis all the way around to the hypotenuse, but we're just looking at that little triangle that's created in the third quadrant, and the reference angle is 60. And then similarly, if we come over to 300 degrees, we'll also have a reference angle of 60 degrees. So I put the website in the PowerPoint if you want to check out this cool website. Let's go back over here. This shows you how to determine what the value is if you're not sure. If it's in the first quadrant, you're going to, over here in the first quadrant, you're just going to have the angle be exactly what it is. If you're in the second quadrant, you're going to take 180 and subtract the angle to get the reference angle. In the third quadrant, you're going to take the angle and subtract 180. And if you're in the fourth quadrant, you're going to take 360 and subtract the angle. Let's do an example. In the first quadrant, let's say that maybe the angle was 37 degrees. Well, then the reference angle is also going to be 37 degrees. In the first quadrant, it stays exactly the same. In the second quadrant, suppose that the angle is 115 degrees. Then our reference angle is going to be 180 minus 115, or 65 degrees. If we're in the third quadrant, suppose that the angle we have is 212 degrees. We're going to take the angle we have and we're going to subtract 180 from it. So the reference angle is going to be 32 degrees. And in the fourth quadrant, suppose we're at 317 degrees, we're going to take 360 and subtract the angle. So the reference angle is going to be 43 degrees. Notice that all of the reference angles are always acute, meaning that they are less than 90 degrees. And there we're going to use that to find the trig values of the larger original angles that we had. So to find the trig functions for angles that are not in the first quadrant, and again, this non-quadrantal means that they're not 90 degrees or 80 degrees or 270 or 360. They're not ones that are on the axis. We're going to first make sure that we get it to be between 0 and 360. Then we'll find the reference angle, and then we'll find the trig values, and then determine whether they are positive or negative based on what quadrant they're in. Here's that table that we talked about in the last video, and we're going to use this as we go through some example problems. For our first problem, we want to find the sine of 315 degrees. This is already in the range between 0 and 360, so we don't need to change it. But what we need to do is we need to figure out where this is and find the reference angle. So 315 is going to be over here, right? So we said that we're in this, and our angle goes like this. So we want to figure out what this is, because that's going to be our reference angle. So to find that, we'll do 360 minus 315, which is 45 degrees. All right. So I'm going to go back up to my chart, and I'm going to say, okay, the sine of 45 degrees is square root 2 over 2. So I know that this is going to be the square root of 2 over 2. The signs are going to match. I just have to decide whether the answer is going to be positive or negative. We said that cosine relates to the x value, and sine relates to the y value. So because we're in the fourth quadrant, y's are always negative here, right? Our coordinates are going to be positive for x and negative for y. So I think that because sine is related to y, that this is going to be a negative value. Another way to think about this is based on what the triangles would have looked like. For a 45-degree angle, I would have had a triangle drawn here. This is 45. And then here, I would have had an identical triangle drawn. And so what we're talking about is this being related to the sine versus this value down here. When I go up, this value is a positive number. When I go down, this value is a negative number. Right? So that's where the sine is coming from. So this is our answer, negative square root 2 over 2. You can plug this into the calculator to check. Plug in sine of 315 degrees. Make sure that your calculator is in degree mode. But again, on an exam, I want you to draw a picture and show me the reasoning of how you got it to show that you know how to find this without just using a calculator. All right, second example, cosine of 150 degrees. 150 degrees is going to be in the second quadrant. I think it's going to be about here. This is going to be 150 degrees. And so I'm looking for this little angle here as the reference angle. And since that's 150 this way, this is going to be 30 degrees, right? So I'm using 30 degrees as my reference. I'm going to go back up to my chart and look at the cosine of 30 degrees. So I'm looking at this one, square root 3 over 2. So I think that my answer is going to be square root of 3 over 2. I just have to decide whether it's positive or negative. Again, cosine relates to the x value. And in the second quadrant, x is a negative number. X is negative and y is positive. So I think this is going to be a negative square root 3 over 2. Again, you can plug this into the calculator just to double check. All right, now we have a negative angle. Let's draw a picture to figure out where. Actually, the first step, if it's a negative angle, is we want to get this angle to be between 0 and 360. So let's add 360 degrees to make it positive first, and I get 120 degrees. That's similar to the one that we just did, right? Oh no, we just did 150. 120, oops. 120 is going to be up here. So this is 120. So our reference angle here is going to be 60 degrees. So we want to know what the tangent of 60 degrees is. We go back up to our chart. The tangent of 60 degrees looks like it's square root of 3. Now we just need to decide whether that answer is positive or negative. In one of our videos, we talked about all students take calculus. So in the second quadrant here, sine is positive, but everything else is negative. And since this is tangent, we know that this is going to be negative, a negative value. Let's do one with cosecant of 300 degrees. That's going to be over here. 300 degrees is like this, and the reference angle is going to be 60, right? Now, cosecant is the reciprocal of the sine. So this is going to be the same as 1 over the sine of 300 degrees. I'm going to flip that upside down. So let's look at our chart. Oh, sorry. And then because it's a reference angle, we're going to use 1 over the sine of 60 degrees, right? So this is just taking the reciprocal right here. And this is changing it into reference angle. All right, what was the sine of 60 degrees? The sine of 60 degrees was square root of 3 over 2. So we think that this is going to be 1 over square root of 3 over 2, or taking the fraction and flipping it upside down, 2 over square root 3. We'll rationalize that. So I'm getting 2 times the square root of 3 over 3. And since we're in the fourth quadrant over here, the y-coordinate is negative, so this overall answer is going to be negative. Remember, sine and cosecant are reciprocals, so if the sine is negative, the cosecant will also be negative. Secant of negative 130 degrees, 135. We'll first make this positive by adding 360 degrees. 225. And then we'll figure out where that is. I think that's going to be over here. So this is the reference angle right here. It always goes from the terminal side to the x-axis. So this is going to be -225 minus 180. which is 45, right? Now remember, secant is the reciprocal of cosine, 1 over the cosine of negative 135 degrees. But we're going to change that to the reference angle, cosine of 45 degrees. The cosine of 45 degrees is square root of 2 over 2. So this is going to be 1 over square root 2 over 2. Or really what that means is flip the fraction upside down. 2 over square root 2. And then rationalize it. So for our answer, we're getting 2 times the square root of 2 over 2. But these two things are going to simplify. And I just have the square root of 2. Secant is related to cosine, and in the third quadrant here, x is a negative, y is also negative. So our answer overall is going to be negative. All right, last example. Cotangent of 210 degrees. 210 is over here. 210 degrees. The reference angle is going to be 30. I got that by looking at 210 minus 180. If we go up to the chart has all 6 trig values. I was in those first examples just showing you how to use the first 3 to find the other values, but we do have the cotangent here of 30 degrees, which is square root 3. So we know that this is going to be square root of 3. You'll notice that on your calculator you don't have a cotangent button, but what you can type in the calculator is 1 over the tangent of 210 degrees, because that is tangents is in the calculator. What we need to think about is, what is the sign? Is this positive or negative? And using our mnemonic device, we said all students take calculus. So this means that tangent is positive here because of the t. And since cotangent is the reciprocal, this is also going to be positive. So I think our answer overall is positive square root 3. All right, send me an email if you have questions. Thanks for watching, and I'll see you in class.